right, if we are looking at the electron configuration for sodium, we're going to start the electron configuration the same way that all of our electron configurations start, which is with 1s. And in the 1s sublevel, how many total electrons would sodium have? 2. So after 1s, then we go to 2s, thank you. And for sodium, 2s would have 2 electrons, and then after 2s, we go 2p. And for sodium, it will be full, so 2p6. And then after 2p comes 3s1. So we stopped there because sodium is in square 3s1. So we had to go through all of the elements that came before it. Sodium is also atomic number 11, which means that it has 11 protons, and that number is never, ever, ever changing. This also means that as an atom, a neutral atom, it would have 11 electrons. And the number of valence electrons we wrote up here, that it's going to be the outer s and p sublevels. So if I'm looking at its electron configuration, I'm looking for the highest energy level in any s and p sublevels. So for this one, it would just be 3s, and I have 1 electron, so my valence electrons would be 1. So as a reminder, your valence electron or your valence shell, this is your outermost shell.
Hey, Ms. Colson, it's mind if I leave at 2:50?
Okay, sure.
And you and I can work doing the makeup test tomorrow.
Okay. And then the Bohr model for sodium is going to have 11 protons in the center. We already mentioned that it would have some number of neutrons. It doesn't matter for this Bohr model. So we're just going to put our protons in the center. Random number of neutrons, doesn't matter. And then we're going to depict all of our electrons on this. So first we'd have energy level 1. And in energy level 1, we have just 2 electrons. So 1, 2. Then in energy level 2, we have energy level 2 in the S sublevel and in the P sublevel. So we'll put all of those electrons onto the same ring. So 2 plus 6 would give me how many total electrons on the second energy level? 8. You can also get this from your periodic table if you don't draw the electron configuration first. So 1, 2, 3, 4, 5, 6, 7, 8. And then I have a third energy level as well. So in my energy level 3, there's just 3s, so I have 1 electron there. So looking at this is the most common way to get your valence electrons, but I did want you to also know that it's S and P from your electron configuration. But if you're looking at your Bohr model, each ring is numbered going out, so this is energy level 1, energy level 2, energy level 3. Energy level 3 would be my valence shell currently, and it only has 1 electron in it. That's my outermost ring, so that is where I got my 1 valence electron. So for sodium, it's options to have a full valence shell, remembering that most energy levels need 8 valence electrons except for energy level 1, which only needs 2 electrons. In energy level 3, that means that a full energy level 3 would have 8 total electrons, where this one already has 1. So if I have 1 and need 8, how many would I need to gain? Bye. So it could either gain how many? 7. Or its other option is that it could lose however many are in its valence shell currently and drop down to the lower energy level. So that would just be 1 in this case. Your atom is going to do whichever thing is easiest, meaning moving the least number of electrons. So if I'm moving 7 versus moving 1 electron, this one is going to be easier, so that's what it's going to do. So I'm going to lose 1 electron. And if sodium loses 1 electron, the ion that's formed, we're going to represent it with its symbol, and then we'll come back over to this side. So if I had 11 protons and I did have 11 electrons, but then I lost 1, how many electrons do I have now? Instead of 11, I have 10. So now I have 10 electrons. 11 protons and 10 electrons means that I have 11 positive things and only 10 negatives to cancel them out. So I'm left with an overall charge of positive 1. So my ion that's formed is a +1 charge. We could also write that as Na with a 1 plus charge. That's what it looks like in a lot of textbooks. They'll write it backwards like that. I'm really not picky when we're writing it. And then the other way that you'll see this, since it's just 1, is it could say Na with just a positive and no number next to it.